Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet and we were following stack data structure, following the very first pattern which is monotonic stack. Today we will solve the next question, which is largest area, largest rectangle in histogram. As you can see, it's from hard topic, but trust me, it's not. And if you found this question hard, then trust me, watch this video till the end and you have to comment on your own ki yes, you understood and this question was not so tough. So let's read the problem statement. It says we will be given an array of integers called heights, representing the histogram bar's height basically, and width of each bar is 1. Okay, every bar height and width is for fixed 1. You have to return the area of the largest rectangle in the histogram. So as you can see, with this 5 and 6, if you will compare 5 and 6, obviously when we want to calculate the common area, we will go with the minimum height in between both, right? And the width will be 2. So 5 cross 2, which is 10, and here in this case 10 is the maximum area. Yes. Now let's see the constraint. Constraint says height length can go till 10 power 5. Why we read this? Because if n is 10 power 5 and if in any case we try writing the brute force code with n square time complexity, then 10 power 5 will become 10 power 10. And you know, if you are following my playlist, then beyond 5 into 10 power 8 or 10 power 8 sometimes, and for sure beyond 10 power 9, it will give us TLE. And hence what we do in this case, we optimize it. But before optimizing, let's see the brute force code for this and let's try to understand how and why I said this problem is easy. So we have to calculate area as per the given bars. Okay, bars means heights. Okay, so basically if I am present at this 2, suppose I don't know anything further. So if I am at 2, what can I say? What is my maximum area till now? So what I'll do, the height and width we will multiply and the area will be 2, and as we have to return the maximum area, so definitely we'll make a variable called max area where we'll keep on storing our maximum area we have discovered so far, correct? Now after this, when I go to 1, correct, so what can I say? What will be my maximum area till now? So can I say this will give me 1 cross 1, which is 1, correct? And till now I have to calculate now. So definitely I have calculated area with this 1 height, and now I would like to calculate the area with this 2 as well. So in this, the common area, what can we, how can we calculate? Can I say minimum height? Yes. And the width will be, if suppose I pointer is here and j pointer is here, we know we calculate width by j minus I plus 1. So if j is 1, I is 0, so 1 minus 0 plus 1, which is 2. So in this case 1 cross 2 will be the area, which is 2, and hence here the maximum is 2 itself, so we will not update. Now we'll move to the next pointer, which is 5. Obviously with 5 we'll calculate the area, and that will give us 5 multiplied by width, which is 1, so hence 5, and as of now 5 is my maximum area so far. Now with 5 we'll calculate with 1 also. So now we'll combine 5 and 1. So what is my minimum height? Can I say 1? And this is a common area also, correct? So width 2, height 1, 2, but here 5 we already encountered. So as of now 5 is my maximum. Again I'm standing at 5, right? So till 1 I have calculated. Now I want to go back again. So now I want to consider all this. But in this, what is my minimum height? My minimum height is 1 and width is 3. So total area 3. But as of now 5 maximum, so we will not update. Okay. Now we will move to the next one. So what I am actually doing here, can I say, we can do in both ways, like move ahead, and whatever you have discovered, go back again to calculate the minimum height so far and the width, multiply it and take the or update the maximum. Or else, if I am here, I will say with this 2 height, like for this 2 height, calculate area, go ahead, calculate area, go ahead, calculate area, calculate. Means standing at 2, what can be my maximum area? So I'll say as of now 2 is my maximum, so 2 cross 1. Once I encountered 1, so going forward, like till now, what is the minimum height? 1, correct? Yes. So although width will increase, but height is 1. Now if I'm at 2 only, after encountering 1, even if I encounter 5, even if I encounter 6, but what is the minimum height? Because 1 came in between. So no matter whatever height comes next towards, because of 1, the height will be 1 itself. So for 2, 1, height is 1 multiplied by width 2, 2. Now 5 encounters, still height is 1 but width is 3, so 3. Now 6 encountered, still the minimum height is 1, so height is 1 but width is 4. Similarly this, okay. Now for 2 so we have calculated and we have got, because of this 1 and width 6, 6 is the maximum height, correct? So for 2 we will update 6 as a maximum height. Now we will stand at 1. So again for 1 we will see 1 cross 1, area is 1. 1, after 1 I encountered 5, but as the minimum height is 1, so height will be 1 but width will be 2. Next time 6 encountered, but minimum height is 1, width is 3, 4, 5, because this is a common area, correct? So height is 1 and width is 5, but 6 is a maximum area, so we will not update this. Yes. Now next time we will be standing at 2, and now we will do for 5. What is the height? 5 cross 1 width 5, but maximum area is 6, so we will not update. Now for 5 we will go ahead. What is the minimum height in between? 2, 5, and area width 2, multiply area 10, and now we can say yes, we got the maximum height, so we will update this. Okay, so for 5 with the help of 6 we have got maximum area 10. Now we will encounter 2. As we encounter 2, so now what can I say? Area will calculate by 2 height. Yes. So minimum height is 2 and width is 3. So 2 into 3 6, as 10 is maximum, so we will not update. Now again for 5 we will encounter 3, but as 2 is the minimum height, so every area will calculate as per 2, correct? 2 into width is 4 means 8. So till now 10 is the maximum. Now we will move forward at 6. Again let's do fast. 6, correct? Area is 6. Now once we encounter this, area will be calculated with the help of minimum height 2. So 2 into 2 4. Again 2 into 3 6. Maximum height is 10, and when you will move forward you will see 10 is the maximum height. So what we did, you can do in either of these directions. So let's move towards right side. One by one you will start, like you will keep your pointer, I pointer at every index, correct? And now you will run your J pointer from ith index to last index. And how you will calculate the area? Whatever whatever indexes you are encountering, let's say you have put I here, correct? Now you will put J here. Now what you will say, like what area, what height is minimum, ith or jth? You will say 2 itself, okay. And now with the help of j minus I plus 1 you can get the width. Now again you will encounter this next index and you will say 1 is the minimum height. So now minimum height is 1 and width is j minus I plus 1, which is 2. So this is how you will keep on running your j pointer onwards, and for every ith you can get the what? Maximum area, and you will keep on updating in the maximum area variable. Yes. So can I write the code here? I want to run the for loop for int I is equal to 0 to I less than last index, can I say heights dot length? Yes. And I plus plus, correct. Now I want to run the second for loop, int j is equal to I. From I want to start, correct? Because if you see, when I was at second index, suppose I, so I wanted to calculate the height from this index onwards, correct? I don't want to go back. So hence we will start the index from I, j less than heights again and j plus plus, correct. Now what I want to do, I want to update my height variable, and that will be math dot min, correct? Whatever height we have encountered so far, and this height we can say ki int height is equal to height, height of I. So first we'll consider h is equal to what? Height of ith index, and now going forward we'll maintain the minimum height as h is the minimum height or height of j is the minimum height. Whatever will be the minimum height as per like for area, we'll calculate as per that height. Now for area we want width also, correct? So width we can calculate by j minus I plus 1, and now area we can calculate height into width, correct? And now this area we have to update in max area. saying कि max area will be math dot max of max area so far and the current area we calculated, what is the maximum, correct? After coming out we can just return that max area. Yes, this is the best. So what is the time complexity? If you see, we are running this for loop for n number of time from 0 to last, and this j loop is also we are running for, like for every ith index we are running this for like first time n minus 1, second time n minus 2, n minus 3 and so on, which will give me O of n square time complexity, like nearby to O of n square only. And if you remember, n was 10 power 5, so definitely n square will become 10 power 10, which is greater than 10 power 8 or obviously 10 power 9, correct? So this will give us TLE, correct? In every code we talk ki why beyond 10 power 9 or nearby to 10 power 9 also can give us TLE, and sometimes when the code complexity is too high, even 10 power 7 code or nearby to 10 power 8 code can also give us TLE. But as the calculation and the logic here is so simple, so definitely till 10 power 8 is safer. It will be slow but it's safe, and beyond that it might give us TLE. So now we have to optimize it. How we can optimize? Whenever we talk about optimization, we talk about different patterns we have learned so far, correct? So we can think about 2 pointers, sliding window, stack data structure, etc. Why I said stack data structure? Because whenever we are standing at some point and we go forward or we go backward to calculate the highest or lowest, we can think of stack data structure, right? Ki why to go back again and again? Why not to maintain the largest value or smallest value till now? But if you are thinking ki why can't we think for a 2-pointer approach, because in the containing most water or trapping rainwater also we did the similar logic of 2-pointer, so why cannot we apply it here? Yes, that let's try to understand that point ki why 2-pointer will fail for this case. Very first reason is, if you remember in the trapping rainwater, we were calculating this area, okay, like where can we trap the water. So if we are calculating the water for this much, okay, so can I say this point, for this point in trapping rainwater, for this point we were calculating ki how much water I can store here. So for that I was finding the nearest left maximum and right maximum, and left maximum was 2 and right maximum was 5. So the height of water will be decided with the minimum height, correct, and this width, yes, and subtraction of this solid here. If you have learned that solution, like we already discussed in the 2-pointer approach, if not yet in the 2-pointer approach, then definitely you can get this. Otherwise I'll just add the link somewhere here, you can get that, like you can read or check out the solution first, the idea behind why we applied that concept, and then you can jump onto here. So I can say if I am standing at here and the water I'm going to calculate here now, like with the help of 1-pointer, I'm not going to use this one height in my future again. Like suppose I want to calculate the next water, so with the help of 2, 6 and 3 I can calculate. These things I don't want. Can I say this? Yes. But in largest histogram, this one can help us to calculate the area for this one itself, 2, 1 also, and this one can help us to calculate the area for a longer width also. So till now let's suppose the area is 10, correct? Or let's say the size is 1, again 2, again 1, again 2 and so on for let's suppose 12 size. So definitely this one will give us 0 to 12 means 13, width into 1 means 13 area, but 5 and 6 was only giving me 10 area na? So this one can help me give the maximum area as well. So this one we cannot ignore as we were ignoring in containing most water, correct? So hence 2-pointer we can apply there. Ki yes, we have calculated, so we can move forward or move our left pointer or right pointer behind or forward. But here every point can help us in calculation of the largest area. So we cannot leave once we calculated some area with the help of that pointer, correct? Yes, and not only one, every pointer is responsible. Yes, so hence we cannot apply 2-pointer. Sliding window also we cannot apply, because sliding window we apply whenever we want to talk about continuous subarray or substring, correct? And here we don't need that. So hence we need a smaller or larger value. Why I said this? Because obviously when we are talking about the areas, we are dependent on the minimum height, correct? So hence we can think of stack data structure, and basically we use stack data structure whenever we have to talk about, whenever we want to go forward or go backward to calculate the maximum or minimum out of something, then we can think of stack data structure, because that reduces our time complexity from O of n square to O of n, correct? Yes. Now let's see how we can apply that stack concept here. So the rule is very simple. As we found 2, okay, we found 3, we found 4, we'll keep on adding all things in the stack, remember, okay? Once we are finding the greater things, we'll keep on adding, and the moment we found the smaller height, we'll stop, okay? And now we'll calculate the area for this, and for this, okay? Now, idea is very simple. What? We'll keep on adding all the heights in our stack until we found any smaller height value. Okay, now once we found the smaller height value, suppose here, correct? So we are not going to calculate area for this. No, if we are here, what we want is 2 smaller values, left side and right side. How can I say this? Once I found the smaller value, I can say for this, my left side and my right side both are smaller. Can I say this? So hence, can I calculate the area for this? Yes, I can. And as this element, like this index, I already stored in stack, this I am currently present. So suppose j is this and I is this. So how we calculate the length? Can I say j minus I plus 1? Yes, we do so. We do. But when my ith and jth index are valid, in this case, ith and jth index are not valid. Correct? So we'll do minus 2. Minus like 1 minus for I, 1 minus for j. Yes. So this together will become j minus I minus 1. And with this we will calculate the width. Correct? And the height will be, if I am here, stack dot pop means top element will be the height. So for this we'll calculate. Okay. Now for next, how we'll compare? We are present here. So stack dot top element is larger than me. Yes. So we'll calculate area. Once now we have popped. So this is not present in my stack. Next time again, is this larger than me? Yes. So now we'll again pop. Correct? This height will pop. And for this height, can I say this does not exist in the stack, right? So this is the left smaller, this is the right smaller. So again for this, I'll calculate the area. But how I'll calculate the area? So this is my I and this is my j. I and j will be smaller elements, means left smaller and right smaller. So I want to calculate the area. So can I say when ith and jth index are not valid, so width will be this. But you will say this is so not present in the stack also. Yes, it's not present. But if you remember, definitely this value was greater in height in stack. Then only it got pushed in the stack again and again, right? Once we found smaller, we stopped. So definitely this is greater in height. So can I say if we'll consider this 2 width with this height, because this is minimum and this was greater, so I can calculate this area as well without even presence of this. Can I say this? Yes. So with this idea, we will keep on running the stack and we'll calculate the area. Correct? So let's do the dry run so that you will understand more clearly. I found 2. So what I'll do? In the stack, I will add 2. Correct? I added. Okay. Now once I added 2, I went on what? Okay, 1. So I am present at 1. And what was the rule to stop if I found any such height which is smaller than stack previous element? Yes, it's smaller. So now it's time to calculate the height. Can I say? Yes. So this will be j. Okay. Do we ever calculate as per the jth index? No. We calculate for this, which is stack dot top element. But we wanted left smaller and right smaller. Right smaller is there, which is j, but left smaller is not there. How we'll calculate? This we can assume ki if our stack is empty, we will, like, instead of doing this j minus I minus 1, we'll simply say ki jth index is the width. Okay. Okay. So can I say if my stack dot is empty, so what I'm saying, width will be what? Width will be jth index only. Else width will be what? J minus I minus 1. Very simple rule. Okay. So for this, the width will be directly j, which is 1. So can I say this? Yes. So what will be the area? 2. Okay. But we need to pop this. Yes. Yes. Second reason is why we are popping. If you see, we found a smaller element, correct? Yes. So in future, in future this 2, like with this 2 so we are not going to calculate area. Are you getting? Because as we have found 1 now, so in future either we are going to calculate like towards the right side, either we are going to calculate as per 1 or anything minimum here we found, but not as per this 2. That is the reason we are popping it out, and that we were doing in using 2 for loops. We were considering yes, this will be helpful, but don't you think this is not required to calculate the area towards the right side? So hence what stack does, it just eliminates the unnecessary heights, correct? So hence we removed from the stack. Now we'll add this 1, which is, remember, we'll add index and not element. Okay, with the help of index also we can calculate how heights of stack dot peak, correct? Yes. So now 1, after 1 we found 5 greater, so we'll simply put the index. Again after 5 we found 6, again greater, so we'll put the index 3. Now the moment we reached where? The moment we reached at 2, which is jth index. Now we can say ki after 1, 5, 6 we reached at 2. Means I know one thing, ki as I reached a smaller value which is 2, for sure in future either the area will be calculated with my height because I am the smaller, or else anything in between, correct? Yes. So hence we have to cancel all this. Now if you are thinking as per 1 also we can calculate now, I'll clear that out. Okay, that was the reason I calculated width like this. I'll show you how we can do that. I am at 2. Okay, so what was the rule? Ki we'll calculate area for stack.pop. So because we have left smaller and right smaller, and unfortunately you will have it if you follow the rule, means as you are finding the greater values, push in the stack, and once you find a smaller value, stop. Okay, so now what is the smaller, like left smaller? If you will pop this index, okay, so in the current height you will say stack dot, like how, sorry, heights heights of stack dot pop. Okay, can I say ki h will have current height which is 6, for which I have to calculate. Now left height, which is I'll save it here. Okay, or without saving also you can say stack dot peak is your left smaller height and right smaller height is your current element. Yes. So how we will calculate the width for this? Definitely height will be 6, correct? And width will be, is a stack empty? No. So how we'll calculate? J minus, as we don't have I, so we'll read like J minus stack dot peak, which is nothing but I only, and minus 1. So what is J? J is nothing but 0, 1, 2, 3, 4. What is stack dot peak? 2. So can I say 4 minus 2, which is 2, and minus 1, which is 1. So now we are calculating the area for this 6, and area will be 6 into 1, which is 6. So maximum area will be 6. Can I say this? Yes. Now, okay, we popped it. Again, in the stack, we saw ki hey, this is also greater than me. Means now I can calculate area for this also, correct? So what we will do? We will pop this. So next time height will be what? 5. Yes. And as in our stack we have this 1. So J will be 4. Stack dot peak will be 1. So J, which is 4 minus 1, correct? And minus 1 as per the formula. So we'll get 2 width. So width will be 2 and height will be this 5. That's what I was saying. 2 into 5 will be 10. So hence now 6 is not in my stack, but still I know I can blindly go with this 5 height because I knew one thing. In the stack, it was only got pushed because it was greater than me or equal to my height. So hence I can say ki with the help of my height, like 5 will say, with my height now you can calculate. So hence 5 into 2 will give me 10. So as of now the maximum area is 10. Correct. Now again this one will say, am I greater than you? It will say no. So hence after this 2, which is 4th index, will get inserted and J will move towards right side. Why I said? In my stack now, I am only maintaining the heights in the smaller way. Means 1, means 2. Because I know either with 1 or either with 2, area will be calculated. 5 and 6 will not help. And if it was helping also, wherever it was helping, means 5 into 2, I have already calculated, so no need to store in the stack. Now next time, again after 2 I found 3, so this will as it is get inserted, but 1, 2, 3, we to have not calculated area as per 3 height, 2 height and 1 height, correct? But we only calculate when we got a smaller value. Here we don't have, so how we'll calculate? For that, in the stack you will add a 0 height element only to calculate the leftover elements. So I'll say it is 0. Why? Because obviously in the stack I will have greater than 0 heights. So now with the help of 0 I will calculate area for every heights present in my stack. So as I am 0, correct? So what I'll do, from my stack I'll pop this 3. So in my height I will have 3. Left smaller element will be stack.peak, which is 2. Right smaller element will be 0. Height is 3, width is 1, area will be 3. As the maximum height is 10, so I'll not calculate. So I'll pop this 5. Can I say? Yes. Now, as this 3 is already done, let me color this. 5 is done, 6 is done, this 2 is done, and now this 3 is also done. Now what I'll say, with this 0, I want to calculate the height with 2. Okay, like I'm saying, with the height, like with the help of this 2 height, till where can I calculate the area? Correct? Again, see, I am here, J. Correct? See, this is actually a magic. You are calculating area for 2, and if you remember, with the help of 2, till where this 2 can help? Can I say from this width to this width? I can say till 2, correct? So see the magic. I have height 2. Left smaller value was present at stack.peak 1. Right smaller value is present at J, which is 6. See, J 6 minus stack.peak minus 1 and minus 1. What it will give? 4 width. So hence, without actually having all the values, I can simply say that this 2 area, like this 2 height is valid for 4 width, and simply we'll multiply with 2 into 4, that will give us 8. Unfortunately, this is not the highest area, but we actually calculated it without having all the elements in the stack, and that's how stack helps us, which is monotonic stack, means increasing or decreasing. Here we are using increasing stack, correct? Now 2 will also get popped. Yes, so it's done, and 4 index will pop. Now for 0, we will pop this, and in height will say I have 1, but for 1, right smaller element is this, but left smaller is not present, means stack is empty. Can I say? Yes. So when the stack is empty, left smaller element we don't have, so how we calculate the width, which is nothing but J, which is 6. And that's what I said, because 1 is very smaller, so 1 is valid height for whole or entire width. So hence the width is 6 multiplied by 1, it will give us 6 into 1, which is 6 area. Unfortunately, it is not higher, but this is how we actually calculate. Without storing all the elements, just storing monotonic stack, which is in increasing order, we'll save it, and just with the help of left smaller and right smaller, we'll get the value. Correct? And in this way, we have not eliminated the other elements, but we have not saved it or stored it also in the stack. But in worst case, suppose every elements will be in ascending order, correct? And as the rule was, only pop when you find a smaller element. Suppose all elements are larger, so definitely you will end up pushing all the elements in the stack of size n, O of n. Let's suppose 10 power 5. But as remember, we added a 0 value to pop, right? So we'll add a 0 value and we'll end up popping everything from the stack. So in worst case, we used O of n time complexity especially to pop all such elements, correct? And O of n to push all such elements. So means O of 2n instead of n square. So let's write the code for this. First we'll calculate the length, HEIGHTS dot length, correct? And now we'll calculate the max area variable. Let's initialize with 0, and also we want a stack of type integer. Let's call stack is equal to new stack. Now what we'll do, we'll run a for loop for int I is equal to 0, okay, I less than equal to n. Okay, why equal to n? Because we want our I to run till last, because like assuming ki last index value is of 0 height, so that will pop everything, remember? Yes, and we'll do I plus plus. Now what we want? First we'll check in this stack while my stack is not empty. Yes. And what was the popping condition if you remember? What was the popping condition? If my current height, but first we have to calculate the current height also. So can I say int h is current height? It will be 0 if my index is last, which is n, correct? So I'll say if my I is equal to n, means if my ith index is last, then 0, correct? Yes. Otherwise heights of ith index. Okay, why I did this? You can either add this 0 element in the last of heights array itself, and then instead of this you can just simply read int h is equal to heights of I. Okay, I just use the ternary operator considering if my ith index is at last, then I will assume ki height is 0. Now in this, while my stack is not empty and my current height is smaller than what? Heights of stack dot peak. Why? Because in the stack we are actually inserting the index, so that's how we will have to read, correct? We'll keep on popping, but we will pop in a height variable stack dot pop, correct? Yes. So basically the left minimum will be stack dot peak. Okay, we can store it also or we can simply use it like that, but now we want to calculate the width, and that width how we'll calculate? If you remember what we did, j minus I minus 1 we want, correct? So here j is I, so I minus I is nothing but right minimum index. Now we want left minimum index, which is stack dot peak, correct? Minus 1. But we can only do this when we know our stack is not empty, because one time we already popped, so we don't know in our stack it's there or not, correct? So again int width is equal to what? Again we'll say if stack dot is empty, correct? It means ki if our stack is empty, then I want to use what? As it is I, or else like this. Remember, if my stack was empty for 1, like when we compared with 0 and the 1 height, because for 1 we do not have the left smaller element, what we did, if you remember here, like for this 0, when we wanted to calculate for 1, we do not had the left smaller, so how we calculated the width, if you remember, like this. So you can either put in if else condition, or you can use the ternary operator as well, that will be more simpler. So that's what I did, ki if my stack is empty, width will be as it is I, or else like this. Okay, now I have to calculate the area. So int area will be nothing but height multiplied by width, correct? width, width. And now I have to update also, correct? Max area we will update with math dot max, okay, max area comma this area, whatever is the maximum, correct? And after coming this while loop, I have to keep pushing the index in the stack, correct? And after coming out of the for loop, we can say we already have got the maximum area so far, so we can simply return that. So now let's run this code. Where I'm getting wrong? Yes, here I guess we just read the height, we consider the index, but we have to read the value, right? Heights of stack.pop, that's what we missed, I guess. Yeah, because stack.pop was giving me index and we have to consider the height. So now this code we can submit, and I hope this will get submitted. Yes, it does. So what's the time complexity? As you can see, this for loop is going to take O of n, and as I showed ki in worst case we'll pop, we'll push every such elements and we'll pop every element. So this while loop is again going to take O of n, but it's not nested, means for every index we are not popping n times, right? In worst case we'll end up popping every element, which will take O of n and O of n, which is 2n. Again, if you did not understood, I'll definitely recommend you to do dry run on your own and try to calculate the time. Ki for every I what you popped, for every I what you popped, and you can say you can see the time complexity there, that will be linear. So this is your Java code. I hope you understood, and with the similar logic, here is your Python code if in case you guys are from Python background, and here is your C++ code. Again, similar logic, I have not changed anything here, and I hope you understood the brute force code. And if in case you want the brute force code, here it is. whatever we discussed. First for loop we will run for n size, we will consider the minimum height, and the j loop will run for every I from ith to n. Every time we will update this minimum height, width we will read like j minus I plus 1, area will calculate, and will keep on updating the maximum area. But if you try to submit this, this will obviously give you TLE, because the time complexity in this case is O of n square. So hence we have to optimize this, as you can see TLE, because the time complexity here, the constraint was 10 power 5, so n square will become 10 power 10, that will give you TLE. So I hope you understood the reason why it gave TLE. Second, why we could not apply to pointer or sliding window approach, and why only stack we can use, and where to use stack. If you understood this, then definitely you are eligible to go in the sheet and mark the next question as done. And please do let me know in the comment section if you understood the logic, if you understood the explanation, and if you solved the question on your own. And please do like the video and subscribe the channel if not yet subscribed, because to be honest, it takes a lot of effort to make videos for you all, and it actually hurts when I do not get any such comment or like on the video. So please do hit the like button and comment. And actually I'm doing stack topic, and soon we are going to start recursion on demand, because on Instagram also I'm getting a lot of requests to start the recursion along with stack topic. So definitely on your request, if you guys also want, do let me know in the comment section. And if you, in case you don't have the sheet link, I'll add the sheet link in the description, you can check that out. And if you want to connect with me on any social media, I am available all the time on Instagram, LinkedIn and Twitter. So please do reach out to me from there if in case you guys need any kind of guidance. And that's it for this video. Let's wrap up and let's meet in another video with some more interesting questions and topics. So then keep learning, take care of yourself and your family too.